אוקיי, אז אני אגיד בעברית שאני אעשה את המצגת באנגלית. יש לנו פה כמה חבר'ה באוקראינה, שגם חלק מהצוות שלנו הם איתנו, ואני רוצה שגם הם ירגישו שותפים, אז אני אעשה את זה בשני השפות. אוקיי, יותר, אוקיי, סבבה, סבבה. Okay, so we're going to talk about performance and some tales of things that happened in like in our company, in our product, and we'll go through the story of how we handle them, and hopefully you'll gain some insights, and or if not, at least it will be a bit interesting. So a bit about me. I'm lactose intolerant, which is important with all the pieces here. I like playing the piano. I love skiing, and you can see the level that I'm skiing at. I've been building stuff and tinkering for over 20 years. And lately I'm doing a lot of 3D modeling, printing, and trying to shove electronics into them. What can I say? I'm just a regular geek. And of course, I'm a backend developer at Remitly. Most of the time I'm working with Node.js and building lots of services and trying to make sure that they are very performant. That's like the point of this talk. And one extra thing, I'm a bit nervous, which is like important to say because, well, this talk is about performance issues. And the first thing that you need to do in order to, well, work through a performance issue, you need to, well, get one. So I think I have one. I'm having one right now, so I think we're good. Okay, it shouldn't be a personal issue. Okay, so it needs to be like a server-related issue. So let's talk about what an actual performance issue is, or well, let's talk about performance issues in general. They are perfectly normal. It's normal to have performance issues. Okay, that's good, Eric. Everyone gets them. That's also good, Eric. Well, except for us. We're building perfect code. Our code is awesome. It never has actual performance issues, only me as the speaker. And I have to say that Remitly IL does not endorse any of the awful comedy that Eric is going to do throughout this talk. Just had to put that out of the way. So the typical symptoms of an actual performance issue are, and I'm not sure why this is not animated, so sorry, that's my bad. Like you'll get in your service the thing that you're running in production, your like most sacred thing. You might get slow responses, just a bit slower or like extremely slow. That it becomes unresponsive. It might just be using a lot of resources, like it might be stopping the service from working, or just it's very expensive for you to run, right? The throughput can drop, the system might crash, and there are like other signs, but usually this is what happens. Like it's not working nominally, the way that you want it to work, or the way that your customers expect your service to work, right? We're trying to get like below 100 milliseconds response time for our customers, and Google did this research that if you, people can feel those 25 milliseconds. They can feel that difference. So how do you know that you got that, right? Well, you can look at the metrics, but most of us are not looking at the metrics every day, all day, because our code is perfect, so why should we? Usually you get some kind of alert, which can happen through various mediums, right? But most often it just starts with a customer complaint, and if you're having a really bad day, then like your whole customer support center just like is flooded with calls, and people are going crazy to get their hands on your service, but they can't because it's not working. But it will never happen because our code is perfect. Well, you know what? For the first time ever, it did happen. Like our app started and became really, really slow, and at times it was completely unresponsive. Damn it. So the most important part of our app is allowing our customers to send money, and they couldn't do, like it couldn't do that the main job, the most important thing that our business requires of it. We have a performance issue. And this is stressful, and it's a bit more stressful than having this talk. And I'm just putting it here, it's a joke, I'm fine. It's important to look at the bright side. Having performance issues is a growth indicator. Could be that you have more customers, right? Maybe you're having more data from those customers, or data in general. You aggregated a lot of data. Maybe your customers are using your app more, and maybe in ways that in amounts that you didn't imagine they would, right? Scaling. And the same thing with just not the app, but like you maybe have new features. Maybe they're using those features more quickly or more often than you thought they would, which is awesome, right? You develop a feature and it's becoming popular, but you didn't expect for it, and now you're having issues. And on the other hand, right, your processes, the way that you're working, the things that you're looking at to solve that, you're going to become a better developer. Your team is going to become better. You're going to figure out what you're missing when you're going to look at the problem. You're going to figure out what is not there, so you basically can look at it. So you're going to quickly go ahead and add it to your problem. And well, eventually, a lot of things are going to become better, but only after you're going to resolve that bad thing. So yeah, let's get back to where were we? We have an issue in production. Let's solve it. But how do we do that? The first step, well, this is the second step, right? Because first step is to get the actual problem. We're going to diagnose it, to figure out, to look, to start looking at things, because yeah, we know that the app is unresponsive. Okay, so now what do we do? So what do we know about the problem? We know that we have slow response time. Could be it's our fault. It could be a problem that our partners are having, right? Our company is connected to hundreds of partners across the world, and we're dependent on them to give value to our customers. Our response time, if we're not handling it correctly, could be affected by them. Like this problem, specific one, happened during the peak time of the month, the time in the month where we had the most amount of customers online trying to send their money to their families. And usually in fintech, that time is the salary week, because people are getting paid and they want to do something with that money. And I think I haven't thought about it before doing this talk. I haven't thought about it enough, how much of the things that I do in my life is revolving around that. The check that I give to my landlord, that it correlates to when I get my salary. The time when I pay off my credit card bills, that also relates to that salary. This specific problem, we had it throughout a specific day of the month, and it was on and off during that day. So we needed to we needed to resolve it. It happened over and over a few, I think 2 months. We needed to try to figure out the problem and replicate it during that short time when we actually can get valuable data. We were notified by customer support. I'm not sure how helpful that would be, but it's good to know that. And we did get some alerts, but also it's helpful, but we'll get to that later. And we did not release any new features, so it's something that happens due to maybe growth or usage, not necessarily that we deployed something that broke the system. At least that's the hypothesis. So we can look at a bunch of stuff, a bunch of metrics, until we kind of find something that's out of the ordinary, right? That's what you do when you're having something like this. And well, if you get an alert and you configured it properly, then your life becomes easier. Let's look at some data. So just, we got complaints from the customers that the app is slow, right? We want to look at the data and see, yeah, it's pretty slow. At some points, it's getting really slow, right? At 99 percentile, at some points, it's getting to like 20 seconds, which means, okay, our customers are right. And this is like the important part, where things are especially slower, right? We can see that it's like double or 3 times the usual rates on average, and at the peaks, it's really bad. And the culprit of all of this was CPU. We saw that we're reaching 100% CPU usage, well, and even more, right? We see that we're almost reaching 150%. And, well, thankfully, Google Cloud allows for a bit of play here, and maybe there are some like errors in the analytics and all of that. But we found the culprit. Like we know, sorry, not the culprit, but we found the main bottleneck in our system, CPU. Right, so awesome. We got to that point. If we had alerts beforehand, we would have reached this point without even looking at any metrics. And the thing that happens when you're reaching 100% CPU is that your pods start crashing. Boom, boom. Because Node is single-threaded, essentially single-threaded, one slow request affects the other one, and the other one affects the other one. So the more slow the service is, the slower it is for other things to get serviced, even if they're extremely fast. So I'll show it in an extreme case a bit later. But a slow service has a cascading effect on everything else. And when you're reaching 100% CPU, you're getting throttled by the operating system, and there are other fun stuff there, but I won't get too much into that. The most important part and the reason why the pods are crashing is because the way we have it set up, and most companies have it set up, we have a health endpoint on our service called health. And Kubernetes is talking to that endpoint, asking, hey, what's going on? Are you okay? Are you alive? And if that's not responding at the configured time, or it's not responding enough, Kubernetes says, hey, you're not healthy. I'm going to kill you, and I'm going to start you again, and hopefully next time you will be better. So that starts a nice crash loop. So at the time when you need your service the most, it's basically committing suicide. And of course, if it was a sustained problem with the CPU, that would be terrible throughout the day. It was only a specific time, a specific moment, so it wasn't that terrible. But you can see how quickly this can become even worse. Sorry. Okay, so we know the problem is CPU. We understood that it affects other things, and maybe there's another problem lying beyond the CPU issue. But we know that we need to resolve that in order to either find other things or give more room to breathe. And for that, we want to administer first aid, right? When someone is hurt, we administer first aid to them, and then we call the ambulance or whatever. So it's kind of the same thing. The goal of first aid is basically, well, we buy time, and we try to do something that's like quick and dirty, something that's very fast, hopefully, because we're having a problem now. We don't have time to redesign or re-architect the system in order to improve it. And the main focus is our customers, they need one thing right now, right? The most important thing is to be able to send money. Maybe we can disable other things that are maybe also expensive for now, disable, delay, or do something else with them in order to allow them to do the main thing that they want. Maybe we're also running some synchronization of developer stuff, or maybe we're fetching some reports in the background that are also wasting CPU time, so we can also maybe disable them. That's just some ideas. But that's our focus, to give our customers like the thing that they want most, and whatever we can do in the background, we'll do it. And as we're doing this, we also need to remember maybe we are missing some metrics. We'll add them. We are getting more insight. As we remove one bottleneck, it will move sometimes to another place, and we're going to get more insight into the actual issue. But we're trying to buy time. Because we're at 100% CPU usage, there are two ways to resolve that, basically, right? One of them is to reduce consumption. We don't know what's causing that consumption, and it's going to take time and effort to do that, so that's not quick and dirty. We can increase the amount of resources we just give to the system. And yeah, that's what we did. That's the easiest solution that can be done. We're running in Kubernetes. So let's say like we have like, I don't know, 3 pods. The length here is like the amount of the CPU size, basically. So one way to solve it is to just scale it vertically, give it more CPUs or better CPUs or something like that. The other way could be, well, it's throwing money at the problem, right? So it just had to put this cute girl here. The other way is scaling it horizontally, right? Where you're just copying the thing that's serving your customers multiple times, as many as needed. Because then you're spreading the CPU load across all of them, and hopefully that's enough. And again, you're throwing more money at the problem, which might be, thanks Tom, which might be good for now, right? Quick and dirty, we care about our customers more than money at the moment. We'll figure it out soon. The important thing to note here, sometimes you can scale it horizontally. Maybe that's easier because you're set up that way. Sometimes it's easier to scale it vertically because maybe you don't have a lot of customers, but their usage per each one of them requires like a stronger CPU or more of them. So it really depends on your use case which one you go with, and it's not always go to this one or go to this one. What we did both of them, right? We made sure that we had enough room to breathe there. We made our servers stronger, or in Kubernetes language, we had a node that's running pods that are running a node inside of them. So we made the nodes at the top bigger, which is like this green part. And also other things you can try is, and I'm sure you have more ideas, you smart people. You can roll back features that you just deploy, right? We didn't have it, but maybe you did. Maybe you deployed some feature that you can very clearly see that's what made it worse. You can turn off and turn on the things that you don't need. I already mentioned that before. I think it's important to think about planned degradation of user experience, and that's a whole topic in of itself. But it's important to think of that, because maybe there are things that you can turn off that are expensive on the backend side and don't give as much value, or not giving the most important value to your customers at the moment. And for us, we also we had very CPU intensive requests that we could just turn on caching in Cloudflare. Everything that we work with is proxy, like goes through Cloudflare, and you can turn on a feature with a click of a button that just tells Cloudflare, hey, cache this for 5 minutes, and we're saving more time and more like processing for other more important things. So there are a lot of things to think about, tools to be open-minded to and to consider when you're doing such things. And as I said, I'm sure there are like 10 other things or 100 other things that you can do, each with their own tooling and infrastructure. But it's good to be to think outside the box, because these problems require that. I think we're good. I think we're good right now. We scaled our infrastructure. We turned off some things. We moved the things that we don't need. Well, at least for now, right? We degraded some usage. We reduced some things. We cost more money. But it's not sustainable in the long run, right? Everything comes at a price, and we now need to figure out what was the root problem in order to reduce that price or get back whatever we lost. So that requires a deeper investigation into the problem. And for that, we're going to go through some process. So we're going to try to reproduce the problem in our, we'll start locally. Then if we cannot do that, or if we have the tooling, we'll reproduce it in staging. But reproduction is always a good first step for any kind of bug or issue or problem. We're going, in order to reproduce it, we're going to try to simulate the load of our customers. When we started trying to run, I don't know, the top 10 endpoints, we couldn't find any specific issue with them, because, well, any single endpoint is not it's not problematic in it and of itself. And when we simulated the load, also, not always it took us a bit of time to actually simulate load of actual customers, because again, it's not just take the top 10 most used requests, try to run them 1,000,000 times, and then see what happens. Sometimes it will be that easy, and sometimes it won't. And after we ran, after we have that setup that we can reproduce, that we can simulate the load, we're going to profile it. We're going to look at the usages of the functions. If we're having a memory issue, like was discussed in the previous meetup, we're going to look at the heap. There are other ways. If we're having I/O issues, right? And we sometimes can only find that by looking at logs or other metrics or New Relic or other tools. If we find that it's a database issue, then we're going, if it's a RDBMS, then we can look at the explain of the queries, try to find indexes that we're missing. It just goes on and on. If you're having queue issues, if you're using Kafka, that can also get messy sometimes. So I'm not going to go into all of that. Right now, let's remember we're having a CPU issue, and we're going to focus on that because that's what I'm paid for. So in order to reproduce it, yeah, we did find the top request. There are multiple endpoints behind this, but I've simplified it here. Login, of course, a lot of people logging in, we're authenticating them, and of order. Order is the process in which a customer deposits money into the app and then remits it, sends it globally to their family members, usually family members, through the app in one swoop, in one single action. So we call that an order. And we load test it in staging. I'll show you in a second the tool called Locust, and we'll look at the stack profiling using another Node.js tool called Flamebearer. We're not to simplify things. I've created a simple app. It has 2 endpoints: login, orders. the orders endpoint is the interesting one because login just returns success. That's easy. That's like, it should be blazing fast, right? And orders, that's a bit slower one. And in order to force it to actually like use the CPU, I'm just telling it, hey, try to do lots of math problems for whichever amount of milliseconds I tell you. And that would allow us to, well, simulate CPU load in a bit of an extreme case, but it's just here to visualize what we're talking about. So we're taking that app, running it, let's say locally, right? In order to simulate actual users, there's a tool called Locust, where you're, and I'm sorry that this is Python. I know that you expected to see JavaScript here, and you can burn me later, but let me finish the talk. And you're defining it tasks that a user might be doing in your app. So the user might be logging in and might be like creating an order. In more advanced cases, you give it parameters, you actually generate things, but here it's not that important. So here I'm just telling it, hey, when you're calling the order, make sure that it's using the CPU for 500 milliseconds. And you're telling it, after you manage to do any of these requests, wait a bit to allow other users to actually use the service and not just bombard it. It's very easy to run. So like you just need that one file, and then you just run it. You get a nice interface. You tell it, hey, I want to simulate 50 of these users. And after we do that, we get this nice graph. So it just starts running, starts automatically bombarding your service by simulating the load of these users. And we can see that our app is managing to get almost like 4 requests. Like the users are managing to do about 4 requests per second, which is almost nothing. And we can see also that with time, those customers are waiting more and more and more time to get a response to their requests. That means, well, it makes sense, right? We did something crazy. We told it to wait 500 milliseconds and wasting the CPU time. That means for 500 milliseconds, nothing else can be done in that thread. And of course, this would go on and on and on because we don't have anything to limit requests to 30 seconds like many servers have and all of that nice stuff. And the important part, if I'm running it on my laptop and I have 16 cores and all of that, that's not simulating it enough. So I ran it in Docker, and I told it, hey, limit it to like one CPU, and it does actually. Well, of course, it gets to 100%. So the important part here, and there's a lot of queue theory behind this, so I won't get into that. Like the more customers, the more slow your service is, the more customers are waiting, and just a lot of they're just waiting and waiting and waiting to receive a response to the request that they did, and your service is basically stuck. So we can see how vertically scaling it or horizontally scaling it would help. If we vertically scale it 2 times, it should theoretically be twice. If we and the same if we do it horizontally. We'll see that there is overhead in Node soon. And the interesting part is the orders endpoint, which should be slow. On average, yeah, it took, I don't know, 8 seconds or something like that. But also the login, which should be very, very, sorry, I'll go from this. The login, which should be very, very quick, also took the same and a bit more. That means that we have this, like the same effect, because both of them are running using the same execution thread in Node. So one slow thing affects the other thing. We can see it in an extreme case. In the more minute cases, that will be less apparent, but it is always there. And so we managed to replicate some extreme use case of CPU consumption by one endpoint that affects the others in the server. now we want to look at it. We want to see what's actually going on. And well, if we didn't know that this code was the one that is responsible for it, right? We need to find it, right? Because you have I don't know, tens of thousands lines of code. Here it's easy to just open this file and say, yeah, it's called CPU intensive task. We know that this is the problem. If we don't know what it is, we can use something that comes with Node. We turn on profiling. It creates very nice log files that we can, they look like this, just, I don't know, just some weird and random names. And we can convert them to JSON and put them in a tool called Flamebearer, so we can visualize them and see what actually happens in the stack. And this, how flame graphs work, the top is 100%. That means that's all of the CPU time is going under this one. And if we go to under it, it splits into two. This side takes almost 89%, and the other one takes 11%. So we can see something that does parsing of headers taking 11% of our CPU time. So we just used plain express, and we're already missing those 11%. And if we zoom in, we can see here that the CPU intensive task is taking 62% of our app time, which is, for me, was very odd to see, because 62%, we have 38% of overhead on top of a very simple Express app, which is interesting. And here we can see some internals and libraries that are used for maths and other things. And if you click on it, right, because this is, Flamebearer gives you an HTML page where you can just click on something, it zooms in, and you can, if it was more interesting, you could see other, like the things that happen inside of it, but we just have a plain and boring app. This was simple, right? In production, this looks very different. This is how it looked like when we ran it in production. And we actually had to run it in production because it was like simulating it in locally or staging didn't give us enough data, and we wanted to get it straight from the source. So thank you to the infra guys and the team that managed to put it there safely and not affecting our customers too much. So you have this crazy thing that you need to manually go through and look at. And usually, and what we did, we started looking at the bigger chunks. Eventually, this green part, which green should be good, the green part was the bad thing eventually. But if you, there are not a lot of tools here to help you identify what's bad, because this tool doesn't know what's bad. You need to know that. So you can use the search box. You can click around, and you can try to turn off various features, libraries, things, and run it again and see how it behaves and how it affects all of this. And that's what we did. We did a lot of experimentation, turning off different tools that we didn't need that much, or different libraries that helped us, but we could do OK without them for a bit. And eventually, yeah, we got to the point where we turned off one debugging tool, and this was gone. So this is the results of what we did. Yeah, we did direct testing locally. Eventually, we managed to replicate it. But as I said, one of the reasons also why we had to run it in production, because our locus testing didn't show a lot of correlation between the amount of requests and actual CPU usage. So something was going on even more in production. So we tried to use the data of actual users. We did experiment and manage to get even more data and more production-like data by actually simulating from the client. So something like Selenium called Nightwatch, where you tell it, hey, just press a lot of buttons in the app and do it over and over and over again in staging. That also gave us a lot of information. But usually that's not how you do this. It's very slow, it's very expensive, running a client and trying to do, I don't know, 10,000 customers with clients. It's very expensive. You need like very big machines in the cloud. So Locus should be the first phase of everything that you're doing. And for us, eventually after all of that work and looking at flame graphs and finding things, we found that a tool that we use for observability cost us about 8%. A tool that we had for live debugging, but we didn't actually use it most of the time. It was just there for in case we needed it. Took 15% of our CPU consumption, which is crazy. And another tool that we, another library that used for validation, it's called Joy, did some topological sorting with some outdated library, and that took also 7%. It was super expensive. And I know that Zod, for example, recently they announced a new version, a faster version. So we're looking into that because Zod, personally, I think that's an amazing advancement from Joy. This one, eventually we did turn it off. Think about it, 15% of CPU consumption, that means either more buffers for actual customers. That means that when you have a peak, you're removing it, or you're just saving 15% of your server time, and this is for our main service, the one that's being used the most. So yeah, I gave a lot of hints on what we actually did, but we did scale it horizontally. We turned off a bunch of things we had. One of the tools was the live debugging one that we've seen that's using 15%. As always, it's good to upgrade some libraries because many of them have performance improvements. A lot of things that I didn't think about, but started to think about it more as I started working here, is we have a lot of things that are running in the background, and you're gathering them throughout the years. And sometimes someone just sets them up to run at, I don't know, 14 UTC, and then someone else copies it, and everyone is running at 14 UTC. So all of that, if you run all of the workers and all of the cron jobs at the same time, it gives you a big spike in your CPU usage. And 2 UTC is about, I think it's 5 o'clock in Israel time, in I think daylight saving time. So we spread them out. We move them to half-hour times. We move them during the night, and we did that 8% that we had here of observability. We decided that we're fine with that. We got a lot of value from using this tool. It's called New Relic. Many people use it. We said that we're fine with that, but this one, which was unused, costing us 15%, yeah, the heck with that. We'll turn it on when we need it, but not the rest of the time. And the result of this is, well, before we got to almost 150%, the same, like a month after, at our peak, with around the same amount of requests, and well, a bit more because we're growing, we got to 100%, and here we had 150. So you see, it's not completely linear. It's not 15% of that, but we did manage to get below our. We did manage to get below our like most amount of usage in CPU, and this does. Like, it's not from the maximum that Kubernetes gives you. It is from the actual core CPU seconds used. So they are comparable, which I don't know. We thought it's amazing, and then we felt joy from actually accomplishing that. So let's recap. we got an issue, right? Not a personal one, an actual one in production. We diagnosed it. We administered first aid. We did something hopefully better. We went a bit deeper, looked the problem in the eyes, found what's going on in the guts of our services. It wasn't easy. We had a big flame graph to go through, but we did that. And we resolved the issue, at least for now. Right? There are a lot of things that we can still improve, but our customers are happy, the business is happy, and we can go from like panic mode to normal mode. And some final notes. Well, avoid having problems in production. No, I'm kidding. Look at your profiling from time to time. We could have observed this if we had spent time just looking at it, and even once every 6 months or something like that. Some monsters grow slowly, and this one came at the worst time. Load testing is also good, right? You know your peak. You can prepare for it when you're adding new features or big architectural changes. It's always a good thing to do. And a small note about scaling. Even if you have auto scaling in your pods or nodes and all of that, something that's really important is the startup time. Sometimes we have a lot of scripts and a lot of like linear code that we're running in our startup of our services, and it's just you can scale, but you scale so slow that customers are actually affected. You maybe have a lot of room to grow to, but you're not quick enough, and then your customers are getting frustrated, and they just go to a different app. And we have enough competitors that we are continuing and working hard to be better than. If you can look at trends, your graphs grow, and with time you can see trends. Prometheus doesn't, Grafana doesn't always give you that power, but tools like New Relic do. And if you can alert on that, even better. Like if you can alert that you're almost reaching that 100% of CPU usage, do that. As I said, buffers are great. So if we save that 15%, it doesn't mean that we're going to scale our CPUs. We probably leave that and maybe increase it even further to keep that buffer. And well, there's a lot to be said about alert, but that's always good. At the beginning, we don't want our customers to complain to us and call us, and then someone else, I don't know, send us a PG mail. We want the system to tell us ahead of time, so before customers are affected, so that we are ready for it, and it's correct for any kind of issue or bug. And well, until the next issue, I wanted to say a special thanks to Guy. I'm not sure if he's here, but he helped me a lot with this presentation. He's doing Miluim, and he's protecting us from the front line. So thank you, Guy, and thank you.